Hello everybody, I am David Shipley Alexander. Welcome to my Infinite Energy series on YouTube. This is video 8 and the topic is electrical propellentless propulsion. The subtitle could be lifters. Video 6 described a mechanical propellentless propulsion, but this is electrical. A primary reference for this video is a NASA contractor report from around the area 2000-2003, Advanced Energetics for Aeronautical Applications. The work was overseen by Dennis Bushnell, the chief scientist of the NASA Langley Research Center. And he had me investigating a company in Huntsville, Alabama called Trans-Dimensional Technologies, or for short TDT. And they were testing what they called thrusters, which are high voltage asymmetric capacitors. A capacitor has two electrodes with a dielectric or insulator between, but in this case these were very asymmetric geometrically, and that is a key to how these things worked, in my opinion. Two of these thrusters placed on the ends of a 4-foot pipe, PVC pipe, could rotate that up to 60 RPM. So in my reference, which is online, the NASA contractor report, page 74, has a picture showing one of the thrusters. You can see the man's hand as for reference, and there's a big electrode here, a flat metal plate, and then you can't really see it in the picture. There's a very fine wire that comes down by the man's watch from here down to here. Now the company had me measure the amount of thrust produced by the thruster, and I did that by fastening it to a pendulum and then measuring how far the pendulum was deflected from the vertical when the high voltage was applied. And it was 14 millinewtons of force. And the president of TDT, Jeff Cameron, made it very clear that these do not operate, as many people think, by an ion flow caused by the high voltage in air. That's the common perception of how these things work, but the fact that that's what people consent to believe doesn't mean that it's really what the case is. And I'm going to say more about that. So the next year, this company in Alabama introduced the what they call the lifter. And there's two pictures there, page 77 in my NASA contractor report. The dimension here is 3 feet along each side of an equilateral triangle. The bottom part of it is aluminum foil. It's made to be very light, total weight 35 grams, made out of balsa wood, toothpicks. And again, there's the second electrode is a very fine wire held by toothpicks that runs above the larger bottom electrode. When the high voltage is applied, that's this gray box here supplying high voltage. They make the fine wire a positive polarity. The thing just lifts right up, takes off, thus the name lifter, and it's there levitating in air, no propellers, nothing like that. Amazing to see it, and I've seen these up close working. So I've already described this. 25,000 volts was what was required to make that one lift. And another reference is the man in France, J.L. Naudin, who has investigated a number of advanced energy technologies and advanced propulsion technologies. And he collected from the world a list of all those who replicated the lifters, and he stopped counting at 350. There's hundreds of people have all over the world have built these. And he provided some other important information. He said that his information was that these operate even in a vacuum, a high vacuum. That totally eliminates the idea that they work by an ion flow. And then later on, Jeff Cameron of TDT told me that he saw another type of thruster operate in a high vacuum. Naudin also said that to him it appeared the operating principle was that was discovered by the American inventor Thomas Townsend Brown in the 1920s, and he got a patent on it in 1960. Naudin did his own experiment with lifters and found that when he pulsed the high voltage at 70 hertz, he was able to obtain the same amount of lift for 1/4 the amount of power. He got a number 886 watts would lift a kilogram. You could round it up to a kilowatt would lift a kilogram. So, how do they work? I believe that nobody really knows, but I'm going to present a speculation, and I call it that. It is a speculation. If you look at my video 7, it's referring to the extremely high density of what people call the zero-point energy field, which is the another name for the ether in my opinion. And as I said concerning energy, the same thing concerning propulsion. If we can get a little bit of this to move in the way we want to move it, we can achieve something that is remarkable. Or as I tell people, a little bit of infinity goes a long way. So I drew a sketch here, hand-drawn sketch showing an edge view of a big electrode and this little red wire, small electrode. Now, the blue lines represent two things. They do represent the electric field. An electric field line doesn't look exactly like this, but it's going to look pretty much like this, where it comes off of this electrode, then it has to go to the other polarity. Now, it would really contact the red, but I left that vacant there so you can see where the red wire would be. But I am speculating that also we're getting a very slight flow, alignment or flow, but I'm going to say flow of the ether, very slight, but enough to produce a force. That force is up because it's coming from the big one, going to the little one. All these lines are converging up here. They're all going upward by the time they get to the little one. So the force on the wire is up, but the wire is fastened to everything else in the apparatus, so the whole apparatus moves up. That's what I'm speculating. And I've already described that. So there you have a brief introduction to lifters and an idea of how they might really be operating. And I hope to be able in the future have a more clear explanation of how they work, but that's not here yet. So thank you for your attention. I would appreciate a thumbs up. There's space below for comments and questions. And if you subscribe, that just means that YouTube will send you a little email when the next video goes up. So what might I post next from a wide and growing range of topics? I say, stay tuned and find out. Until then, I am David Shipley Alexander.